Hello and welcome back. So in the last class we have studied about determinants and we have studied how to find the determinant of various types of square matrices. In this class we will start a new topic, and that is properties of determinants, and this is an extremely important topic. So today's topic is about properties of determinants. Okay, so let us learn about various types of properties that determinant of a matrix can have, and this is also very important. Okay, so how many properties that we are going to study today? Today we are going to study about 6 very distinct properties of determinants. So the first property is this. Please take a note of this in your note copy. The first property is that determinant of a matrix and that of its transpose are the same. So this is the first property of determinants. The first property says that if you take determinant of a matrix and if you take the determinant of the transpose of the same matrix, then both these determinants will be the same. In other words, or mathematically, determinant of A is the same as determinant of A transpose. So this is the first property, that is the property on determinants. The first property on determinants is that the transpose of a matrix and the matrix have both the same amount of determinants. So determinant of this matrix is the same as determinant of its transpose. So this is the first property that you should keep in mind. So if I show you by an example, let us say that we have a matrix A is equal to 1, 2, 3, 4. So can you find its determinant? Determinant of this matrix will be equal to 1 into 4 minus 2 into 3, and that is equal to 4 minus 6, and that is equal to minus 2. Now take A transpose. What is A transpose? A transpose will be rows will change to columns. So this is the first row, this will become the first column. So first row is 1, 2, it becomes the first column 1, 2. 3, 4 is the second row, 3, 4 becomes the second column. So this is the A transpose, and try to take a determinant of this. So determinant of A transpose will be equal to 1 into 4 minus 3 into 2, and again the same thing, we see 4 minus 6 equal to minus 2. So we see that determinant of A and determinant of A transpose, they are both same. So this is the first property, the properties on determinants. So you have to keep this property in your mind always. Let us move to property number 2. Okay, so you keep this in your note copy. Let's move to property number 2 on determinants, and its statement is somewhat like this. Property number 2 states that if any two rows or columns are interchanged, then the sign of determinant changes. This is the second property, very important property. What does it tell you? It is telling you that if you exchange any two rows or columns, if you exchange them, then the sign of the determinant changes. Now let me tell you a little bit about our history. We have studied about various types of elementary row or column operations, right? So what was the first property? What was the first elementary row column operation? It was to interchange any two rows, right? So how do we interchange two rows? We use this type of symbol, right? That means R1 exchanged with R2 or R2 exchanged with R1. We must have studied it in our previous classes. So suppose we have a matrix A and we are giving A like this 1, 2, 3, 4. Okay, so it has two rows, row 1 and row 2. Now if I perform this operation on this matrix, will its determinant change or not? Let's see how does this determinant change. So we see that A is this matrix, then determinant of A is equal to 1 into 4 minus 3 into 2. So 1 into 4 minus 3 into 2, that is equal to minus 2. Okay, so this is the determinant of this matrix. Now let us perform this operation on this matrix and see what happens. So this matrix would become, first row becomes the second row and second row becomes the first row. So we see that after performing this operation, which operation? This operation. After performing this operation, this matrix becomes this matrix. Okay. Now let's check out what does the determinant, how much determinant does this matrix have. So the determinant of this matrix is 3, 4, 1, 2. It is equal to 3 into 2 minus 4 into 1. And this is equal to 6 minus 4, this is equal to 2. So can you see that this was minus 2 and this is plus 2. So obviously by changing a row or a column, by interchanging a row, if I interchange this row, then if this is minus 2, then after interchanging we get this matrix, then this determinant will be equal to plus 2. That means whatever sign is in this determinant, after interchanging the row or column, you will get the same determinant but with a different sign. Okay. So that means sign changes after you perform row or column interchange operations. So this must be clear to you. This is property number 2. So for example, if I say I have a matrix. Now let me give you another example. Let us say we have a determinant of order 3 by 3. Say this is the determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 3 rows and 3 columns. Now let us perform this operation. Let us say I exchange these 2 rows, row 1 and row 2. So what will happen? We see that this would be equal to, row 1 is getting changed with R2. So R2 comes in the topmost position and R1 comes to the second position and the third row remains the same. So according to the property, this will have a negative sign because when I am interchanging 2 rows, the sign of the determinant changes. So this time when I change this row to the first row and first row to the second row, then this will become this like this and its sign will change. Okay. So now in the next case, what will do? I will change this one to this position. So what will happen? It is already minus now. After changing this, what will happen? 4, 5, 6 will be remaining here. Then 7, 8, 9 will come in the second position and 1, 2, 3 will go into the third position. Then due to this interchanging property and due to the property, there will be another minus here. So minus minus becomes a plus. Now it must be clear to you that if we are changing it one time, then we get a minus. Okay. Then if we change it another time, then minus minus becomes plus. Then if we change it a third time, it will again become minus. A fourth time, it will again become plus. So it goes on like this. So you see, if I perform another operation, let us say I bring 7, 8, 9 in this position and 4, 5, 6 in this position, then it will become minus 7, 8, 9 and 4, 5, 6 will come here and then 1, 2, 3 will remain here. So whenever I perform a row or column interchange operation, I will always have a change of sign. If it is a minus, then after changing it becomes plus. If I change again another row or column, then if it is plus, it becomes a minus here after this change. Okay, so this must be clear to you, and this is nothing but the second property of determinants. Let me give you another example if this was not clear to you. Let me give you another example. Let us say we have a determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. Same example. Now let us change some columns. So let us say you want to bring this column in this position. So what we'll have? You will have a minus because it is plus here. After changing, it will become minus because as the property says, then the sign of determinant changes. So if you are performing interchange operation, then you must produce a minus sign here. after interchange. So 7, 8, 9 becomes in this position 7, 8, 9, and 1, 2, 3 takes the position of 7, 8, 9, and 4, 5, 6 remaining same. So this is for the first time we have achieved a row column, a row interchange. Okay, so this is a minus sign here. Second time if we perform another row operation, then let us say this row becomes this row comes in this position and this row comes in this position. So what will happen? 7, 8, 9, there was a minus previously, so 1, 2, 3 comes here and 4, 5, 6 comes in this position. Now since we are performing another operation, then this minus would become plus this time. So this is how we do with the second property. Okay, so this, I think you must understand, you must have understood the second property by now. Let us do the same thing with columns. This time we have used rows, right? Next time we will use columns here. Let us use some columns. You see it has 3 columns, so let us interchange the first column with the third column. Let us bring 3, 6, 9 here. Let us leave 2, 5, 8 as it is, and 1, 4, 7 comes to this position. So after this interchange, if it is plus, then it becomes minus. Okay, let's interchange it again. Let us say we bring 3, 6, 9 into second position and 2, 5, 8 in the first position. So 2, 5, 8 comes to the first position, 3, 6, 9 goes to the second position, and 1, 4, 7 remains the same. So earlier it is minus, then it will plus. So this is in accordance to the second property. It is telling you if you interchange any 2 rows or columns, then the sign of the determinant will change. Keep this property in your mind, it is very important. Let us move to the third property of determinants. Third property says that if any two rows or columns of a determinant are identical, then determinant equal to 0. What is it telling you? It is telling you that for any matrix which has 2 identical rows or 2 identical columns, then the determinant of that matrix will be equal to 0. So let us say we have a matrix A is equal to, let us say 1, 2, 3, 4, 5, 6, and again 1, 2, 3. So here we say that it is a 3 by 3 square matrix and 2 of its rows are identical. First row is the same as the third row, and according to this property, if any 2 rows of a determinant are identical, then determinant equal to 0. That means if 2 rows are the same, then the determinant of this matrix will be 0. It is guaranteed. So if you try to find out its determinant, you will find that it is equal to 0. So this is the third property. It is a very important property. For example, determinant, for example, what will be the determinant of this matrix? What will be the determinant? Tell me. You see that this row is the same as this row, then determinant will be equal to 0 according to the third property. Okay. For example, if I say I have a matrix 1, 0, 3, then 1, 0, 3, then 1, 9, 2. What will be the determinant? Since 2 rows are same, determinant equal to 0. Guaranteed. Again another example, 1, 2, 3, 4, 5, 6, 1, 2, 3. What will be the determinant? Since 2 columns are same, determinant equal to 0. Okay. Another example, let us say I have 1, 0, minus 1, then 2, 0, 4, again 1, 0, minus 1. What will be its determinant? Obviously this row is the same as this row, so determinant will be equal to 0. So according to the third property, if any two rows or if any two columns are same in any matrix, then its determinant is equal to 0. That is 100% guaranteed. So keep this in mind always. This is a very important property. Let's move to the third property. Let's move to the fourth property. Keep this property safe in your note copy. This is very important. It is telling you if an entire row or a column, if an entire row or a column gets multiplied by k, then the determinant also gets multiplied by k. So it is clearly telling you something, right? So if I give an example of this, you will understand this property very easily. Let us say we have a determinant like this. Let us say this is 2a1, 2a2, 2a3. It is b1, b2, b3, c1, c2, c3. So can you see that one of its rows, that is the first row is getting multiplied by 2. Can you see that? Rest of the rows are not multiplied by 2 or any number. They are just b1, b2, b3, c1, c2, c3. And the first row is getting multiplied by 2. So you can take 2 common outside and express the same thing. That means the whole determinant gets multiplied by 2. So this is equal to a1, a2, a3, b1, b2, b3, c1, c2, c3. So this is what the property number 4 tells us. It tells us if there are some common numbers appearing as multiples in any row or any column, then you can take the common along any row and then you can take it outside the determinant as a product. So this is a very, very important property. You have to keep that in mind. For example, if I would have given here a 3 here, what would have happened? In this position you would have 3 into 2. You could have taken 3 outside the determinant as a common factor, and in the similar way you have chosen 2 here as well. Okay, so 3 into 2 becomes 6. So this is the property number 4. Let me give you another example so that it becomes clearer to you. For example, say I have a determinant 1, 2, 2, 4. So can you see that each and every number here is a multiple is multiplied by 2. In the second row this number is multiplied by 2. So I can say that it is 1, 2, 2 into 1 and then 2 into 4. Can you see that? So 2 is a common factor of all the elements in row number 2. So I can take 2 outside of this determinant. I can say it is just 2, 1, 2, then 1, sorry, it is not going to 2, 1, 2. Okay, so I can take this 2 outside of the determinant. Let us have another example. Let us say we have 2x, 2y, 2z, 3a, 3b, 3c, then minus 4p, minus 4q, minus 4r. So can you express this in this fashion? Taking these 2 outside this determinant, we have 2 here. Taking 3 outside this determinant, we have 3 here. Taking minus 4 outside this determinant, we will have minus 4 here. And the matrix and the determinant xyz, a, b, c, minus p, minus q minus r. Now it must be clear to you that if there is a common factor in any row or any column, you can take that common factor outside the determinant and it will give you this thing. Okay. Now let me give you another example. Let us say you have a determinant like twice a, twice b, twice c, x, y, z, p, q, r. Okay, so in this case, what do you have? You can take this 2 outside and you can just say it is a, b, c, x, y, z, p, q, r. Another example, if I say suppose it is 3 here as well and it is a 5 here, then you could have easily taken all of these common factors. You can take 2 outside, you could have taken 3 outside and also 5 outside this determinant. 2 into 3 into 5. So this is the property number 4. Now here is a very interesting case that I want to tell you, and keep this case in your mind. You must have studied, for example, let us say we have a matrix A is equal to 1, 2, 3, 4. Let us say a matrix is equal to 1, 2, 3, 4. What is 2 times of A? You must have studied in matrix multiplication that whenever a matrix gets multiplied with a scalar, then all of its elements get also multiplied by the scalar, right? If you move into the matrix theory, you will see that when a scalar number is getting multiplied with a matrix, then all of the elements also get multiplied by the same number. So 2 times of A will be equal to 1 into 2 is equal to 2, 2 into 2 is 4, 2 into 3 is 6, and 2 into 4 is 8. Okay, so this is 2 times of this matrix A. This is matrix. Now what will happen if I say 2 times of A determinant? If I take determinant of this matrix, what will happen? We will see that this is the determinant of 2, 4, 6, 8. So this is a very important point. Keep this in mind. This is a very important point. From property number 4, we have a very important point at this location. So determinant of twice A will be equal to determinant of this, and as you can see that every element is multiplied by 2, as we have seen here, right? Every element gets multiplied by 2. So 2 multiplied by 2 is 1 was getting multiplied by 2, then 4, you have 4 here, 2 multiplied by 2, 6 we have here, that was 3 multiplied by 2, 8 we have here, that is 4 multiplied by 2. So previously we have the matrix 1, 2, 3, 4, 1, 2, 3, 4, but each element is multiplied by 2. Now according to property number 4, this row contains a common factor 2, so I can take 2 outside of here. So we'll have 1, 2 at this location. Then this row contains another common factor 2, so I can say there is another 2 and I can take it outside of this matrix. So in other words, this is 2 square times, this is equal to 2 square determinant of A, because this matrix is nothing but A, right? So this is nothing but determinant of A. So can you notice that determinant of twice A is equal to 2 square times the determinant of A? Can you see that? So here we see that if a matrix is getting multiplied with a number 2, each and every element gets multiplied by 2. Then if you take determinant, then this becomes a 2 square times the determinant of A. So in other words, my very important point here is that determinant of any matrix that is multiplied by a scalar number, this is equal to, if A happens to be a n by n square matrix, if A is a n by n square matrix and you are multiplying that matrix with k and then you take the determinant, then this will be equal to k to the power n determinant of A. This is a very important result. Keep this in mind. You will find its use in various competitive examinations. So if you have a determinant in which every element is multiplied by a number k, then this is the same as k to the power n multiplied by determinant of this matrix A. For example, I can give some examples based on this. Let us say I have a question. Let us say A is equal to 1, 0, 2, 3. Suppose a matrix. And I am also telling you that determinant of A is equal to 3. I am giving you the result, determinant of A is equal to 3. Then what is the determinant? Then what is the value of determinant of 5A? This is the question. Question is that I am giving you a matrix A is equal to 1 0 2 3 and I am telling you that determinant of this matrix is 3. Okay, then I am asking you, then what is the value of determinant of the matrix 5A? That means 5 times you multiply this matrix and then take the determinant. What will be the determinant? So according to this result, what is the order of this matrix? Its order is 2 by 2. That means its order is 2, right? So we know from this theorem that 5 times of A will be equal to 5 to the power, the order is 2 by 2, so 2, it is a second order matrix and it will be multiplied by A. So this is nothing but 25 times determinant of A. This is equal to 25 times determinant of A is 3, so 25 times 3, that will be equal to 75. This is a typical question from your competitive examination. Okay, so now this was all about the property number 4, and it tells you that if an entire row or a column gets multiplied by k, then the entire determinant also gets multiplied by k. You keep this property in your mind. Let's move to another property, property number 5. So keep all of these properties in your mind while solving questions. So I advise you to go through all of the properties regularly. Let's move to property number 5. It's quite long. It says that if sum or all elements of a row or column are expressed as a sum of 2 or more terms, then the determinant can be expressed as a sum of 2 or more determinants. This property is quite long to read, but it is actually very easy. Okay, what is it telling you? If some or all elements of a row or a column are expressed as a sum of 2 or more terms, then the determinant can be expressed as a sum of 2 or more determinants. So let me give you an example and try to explain to you what this property 5 tells us. Let us say we have a determinant. Let us say we have a determinant A plus B, then you have C plus D, and E plus F. So these are the elements of the first row. In the second row you have 1 2 3 4 5 6. So according to this property, if any row or any column has elements in this form, they are getting added. So each and every element of a row or a column are in addition. Then you can do one thing. You can create 2 determinants, 1 2 3 4 5 6. Okay, and on each determinant you take just one part of the addition. So in this left hand side determinant you place only A, then C, then E. A, C, E, and on the right hand side you will have B, D, F, B, D, F, and this is nothing but the property number 5. So if you have any row or any column in this fashion, you can rearrange them using this property number 5 in this way. It is also a very important property, keep this in mind. Another example, if I take this one, let us say we have a plus b, c plus d, e plus f, then 1 3 5 2 4 6. Then you can split it in two determinants like this: 1 3 5 2 4 6, 1 3 5 2 4 6. On the left hand side you take this part A, C, E, any part you choose, and on the right side you choose B, D, F. That means you are just distributing an entire row over the determinant and making two determinants out of it. So this is very easy. Okay, so and this is property number 5. Let's move to the last property of determinants, and this is also quite important. Okay, so let me rub it out. Property number 5, we move to the last property for determinants, and this is the most important property. You have to keep this in mind. This is property number 6, and it is very important. Property number 6 tells you, if to each element of any row or column, if to each element of any row or column the equimultiples, that means same multiples, equimultiples means same multiples, equimultiples of corresponding elements of another row or column are added, then determinant remains the same. Okay, so this is the last property from properties of determinants, and it tells you that if to each element of any row or a column the equimultiples of corresponding elements of another row or column are added, then determinant remains the same. So this is quite lengthy and very difficult to understand, but how can I explain to you in easier fashion? Now remember, let us recall history. Remember, in elementary row column operation you have three types of operation, right? The first operation was to interchange any two rows or any two columns. The second operation was to magnify or demagnify any row or column, and the third operation was to add contents of another row or the multiples of the contents of another row with the first row or first column. Then that was the third operation. So this property tells us if you perform third operation on any matrix, then its determinant will not change. So if I say I have a matrix, if I say I have a determinant like this, for example, say 1 2 3 4 5 6 7 8 9, and then if I perform this operation, if I say I perform R1 becomes R1 plus R2. We have done these things several times in our previous classes, right? So if I perform this operation on this matrix, then its determinant will not change. This is this property, property number 6. So what will happen if I perform this operation on this matrix? This would become, see, R1 is getting changed, so R2 and R3 remain the same. So what is R2? It is 4 5 6, and what is R3? It is 7 8 9. So only R1 gets changed, and that is changing to R1 plus R2. So what is R1 plus R2? 4 plus 1 is 5, put it here. What is R1 plus R2? 2 plus 5 is 7, place it here. Then what is R1 plus R2? 6 plus 3 is 9, put it here. And according to theorem number 6, no matter how many operations you do on this matrix, it will not change its determinant, and that is property number 6. I think it is clear to you that whatever row column operations we have performed earlier, that was the third type of row column operation. Okay, if you remember correctly, what was the elementary row column operations that we have studied? How many types of elementary row column operation that we have studied? First operation was interchanging of two rows or interchanging of two columns, right? The second operation was magnifying or demagnifying a row or column. You must have studied it, right? And what was the third operation? The third operation was adding the contents of one row with that of the other. For example, if I do this operation or if I do this operation, then this is the third type of column operation. And the property number 6 of determinants tell you, if you perform this operation on any matrix, then its determinant does not change. Its determinant remains the same. No matter how much operation you perform on that determinant, its determinant will not change, provided that you perform this operation once on every time. That means if you are changing one row, then at this step you should change it only once. Okay. Now let us solve some examples and see how we are applying this property. So let us say we have a matrix 1 2 3, then 1 5 7 1 9 8. We want to find its determinant. Okay, so we can say that this is the same determinant as 1 2 3, and in the second row let us do these things. Second row change to second row minus first row. Okay, we are changing the second row to second row minus first row. So what is second row minus first row? See, 1 minus 1 is 0, then 5 minus 2 is 3, then 7 minus 3 is 4. Okay, and we are doing the same with the third row. We are changing third row to third row minus first row. So in the third row we are changing it to 1 minus 1 is 0, 9 minus 2 is 7, 8 minus 3 is 5. So writing this determinant or writing this determinant, it is the same, and this is what the property number 6 tells you. You can do as many operations as you like, its determinant is not going to change, and this is a very very important property that you have to keep in your mind. So by using this property, can you see that this determinant has been reduced? How? Because I just need to calculate for this element. All these elements are 0, right? So if I choose this column, then only thing that I need to calculate is 1 into determinant of 3 4 7 5, and see how subsequently, how substantially I have reduced my calculation. It is 3 5s are 15 and 7 4s are 28. So it is 15 minus 28. How much do you have? I think it is minus 13. Okay, so you see determinant of this matrix is minus 13, and using these row column operations, how easily I have calculated its determinant to be minus 13. So it is all thanks due to this sixth property of determinants, which tells us that you can interchange, or you can perform the row column operations like this, and this will not change the determinant. And finally, when you achieve at a very good position, then you can apply the determinant formula and find the determinant. Okay, so this is the property number 6, and it is the most important property. Now let us solve some problems on these properties of determinants. So these 6 properties of determinants you should keep in your mind always, and try to keep them noted in your note copy, and try to recognize each property by their property number. We will use them in our future classes. Now let us solve some problems on properties of determinants. They are very very important. Let's write questions. Okay, question is, prove that this determinant a plus b plus c twice a thrice a plus 2b, then 4a plus 3b plus 2c, then you have 3a, 6a plus 3b, then you have 10a plus 6b plus 3c. this whole determinant is equal to a cube. You have to prove that. How do you prove it? Using properties of determinants. Now tell me, which property of determinant will you use here? Can you use the first property, which says that transpose of this is the same as this? So you cannot use the first property. So tell me, which property is more useful in this case? Can you use the sixth property in this case? Can you use the sixth property? Can you reduce this determinant to only a cube? Okay, for that you need to obtain zeros and zeros at this position, right? How can you do that? How can you attain zeros and 0 at this position? Yes, by subtracting one row from the other, and that is property number 6, I think. So if you remember your property number 6, what can you do so that you can achieve a 0 at this position? Try to find out what can you do so that you can achieve a 0 at this position. You can do this operation. You can change the second row to second row minus 2 times the first row. You can change the second row to second row minus 2 times the first row. So this is your first row, right? If you multiply this first row with the number 2 and then subtract this row from that row and put the result in this position, then it will be 0. So let us see what is the second row. Sorry, first row is a plus b, a plus b plus c. Okay, and second row is twice a, 3a plus 2b, then 4a plus 3b plus 2c. Okay, then what is 2 times of row 1? 2 times of row 1 is equal to twice a, 2 into a plus b, 2 into a plus b plus c. Okay, so we see that in this case the second row can be changed to r2 minus 2r1. So r2 minus 2r1 is equal to twice a minus twice a equal to 0. So we see that the first row is not getting changed. So we have a plus b plus c. Only the second row gets changed, and that's changed to r2 minus 2r1. r2 minus 2r1. So 2a minus 2a is 0. Then 3a plus 2b minus 2 into a plus b. How can you do that? 3a plus 2b minus 2 into a plus b. If you expand it, it is minus 2a minus 2b. So that is equal to, I think, a only. 2b and 2b cancel out. So that means you have a at this position, right? And then in the third case, this minus that. So we have 4a plus 3b plus 2c, and here you have minus of 2a minus 2b minus 2c. So minus 2a minus 2b minus 2c. You can see 2c and 2c cancel out. 4a minus 2a is equal to 2a, and 3b minus 2b is equal to b. So you have 2a plus b. Put 2a plus b here. Okay. So now in the second row we attain a 0 here. Now at the same time, how can you attain a 0 at this position? How can you attain a 0 at the third position? Yes, you have to multiply the first row with 3 and then subtract this row from that row and place the result in the third row. So the operation that you should do now is r3 should be changed, and that should change to r3 minus 3 times of r1. r3 should change from r3 to r3 minus 3 times of r1. So what is r1? Again, first row is a plus b and a plus b plus c, and the third row is 3a, 6a plus 3b, then 10a, 6b, 3c. Then 3 times of row 1, okay. Now in the third row, what do you have? r3 minus 3r1. So r3 minus 3r1 is 3a minus 3a is equal to 0. Then 6a plus 3b minus 3a minus 3b. So 6a plus 3b minus 3a minus 3b. So 3b, 3b cancel out. You have 6a minus 3a, that is equal to 3a. So put 3a in this position. And then finally in this position you have 10a plus 6b plus 3c minus 3a minus 3b minus 3c. So you have 10a plus 6b plus 3c minus 3a minus 3b minus 3c. So what do you have? 10a minus 3a is 7a. 6b minus 3b is equal to plus 3b, and 3c cancel. So you have 7a plus 3b. Okay. So we see that after row column operation, our determinant has changed from this position to this position, and this is possible only due to property number 6 of determinant, which says that if you perform row column operation of the third type, then your determinant does not change. So this determinant and this determinant, they are both same according to property number 6. Now what do you see now? Can you see that these if you evaluate this determinant, then from property number, then according to the rule of determinant, you choose that column or row which has the maximum number of zeros. So this column has maximum number of zeros. So if you evaluate this determinant, it is nothing but a into, hide the row and column. A belongs to first row, first column, so hide it. What do you see? Do you see these 4 numbers? So it is a into a twice a plus b and 3a into 7a plus 3b, and rest all of them are 0, so I am not writing them. Okay. So now how can you again find this determinant? Again you simplify using the sixth property. Again you do one thing, you place it a here, twice a plus b, then again use this property, r2 changed from r2 minus 3 times r1. Again do the same thing in this matrix also. Do the same thing. That means multiply the first row with 3, then subtract the second row from the first row and place the result in this position. According to property number 6, we can do that here as well. So use it and see what happens here. So if you multiply by 3, it becomes 3a. 3a minus 3a is 0. Okay. If you multiply by 3, this becomes 6a plus 3b. 7a minus 6a is equal to a, and 3b minus 3b is equal to 0. So you have only a here at this position, right? Try to do this mathematics in your mind while you practice this type of problems. Okay, so if we multiplied this row with the number 3, so it becomes 6a plus 3b, and this row minus that row is 3a minus 3a is 0, and then 7a minus 6a is equal to a, and then 3b and minus 3b 0. So you have only a here. Now what do you attain? We see that in this column, again this is the column with only 1 0 here present. So this determinant will change to a into a minus this into 0, so it is 0. So can you say that it is equal to a cube? See, this is equal to a cube. After evaluating this determinant, this becomes equal to a cube, and it is now proved that left hand side is equal to right hand side, it is equal to a cubed. Okay, so this is the proof and it is over. So see, we never used the formula of determinant anywhere, we just used the property and finally found that it is equal to a cube. So using the property simplifies our problem. Had we proceeded finding the determinant, it would be extremely complex, because see, if we choose a and then hide this row and column, then we would have multiplied this with that, then we would have experienced a squared ab type of situation. It would be extremely long. But by using the properties of determinants, see how easy the calculation have become, and I have very successfully found the value of a cubed. So it is very important to use properties of determinants. Okay, let's try to solve another example. Let's try to solve another example, and using the property try to find out its answer. Okay, question is, evaluate the determinant using properties. using properties of determinants, try to evaluate this determinant. The determinant is 1 1 1 ABC and then BC CA AB. Try to find this determinant by using the property of determinants. Try to find it out. Think about it. How will you find, or which property we will use to find out its determinant easily? Try to think about the properties. Yes, every time we see that each and every element of a column are equal, then we should try to achieve zeros at this position. So what we'll do, using the sixth property, we see that by using row column operation, I can perform row column operations on this determinant and its value will not change. So I will say this is the first row, keep it as it is, and in the second row I will do this second row minus first row and place the result in second row. So the operation that I am doing is R2 changing from R2 minus R1. So 1 minus 1 is 0, B minus A I placed here, then CA minus BC, we have CA minus BC at this location. Okay, then in the third row, how can I achieve a 0 at this position? Again, third row minus first row. So third row is changing to third row minus first row. See, 1 minus 1 is 0, C minus A, AB minus BC. So according to the property number 6, this determinant is the same as this determinant according to property number 6. Okay, now what can we do now? You simplify this matrix, you see that it is 1 A B C, then here you have 0 here, then here you have B minus A. Can I change it to minus A minus B? Can I change B minus A into minus A minus B? Yes, I can take minus as common, and in this case I can take C as common. It becomes A minus B, taking C as common in this position. Okay, then again we have a 0, then we have C minus A, then you can take B as common, it becomes A minus C. Okay, or if you take a minus B here, it becomes C minus A. Now it is clear to you, right? Now can you use the property number, can you use property number 4? Take a good look at property number 4, which says that if any row or any column gets multiplied by a number, it is as if you are multiplying the entire determinant. So in this row, take a good look at this row. Can you see any common factor in this row? Can you see any common factor in this row? Yes, the common factor is A minus B. Here you have A minus B, that means 0 into A minus B, that is 0. So A minus B, A minus B, A minus B. So take A minus B outside. So what you have inside is 1 A B C, then you have A minus B, you have taken outside, so it is 0. Then here you have minus 1, then here you have C. In a similar way, can you see that C minus A is a common factor in the third row? That means it is C minus A, 0 into C minus A. So if you take C minus A outside, you have 0, 1, minus B. So this determinant is the same as this determinant. Okay, fine. Now you have A minus B into C minus A into this determinant. In this determinant, you see that this column has 2 zeros. So what will be its determinant? 1 into determinant of these 4 numbers. So this is equal to A minus B into C minus A into 1 into determinant of, if you hide the row and column to which 1 belongs, so 1 belongs to the first row, first column, so hide the first row and first column, you see 4 numbers, right? So place these 4 numbers in determinant here. Okay, now what we will do next? How can you find the determinant of this? After doing that, can you add the first 2 rows and placing the result anywhere? So I can say that it is A minus B into C minus A into, take the second row or you take the first row. The first row is minus 1 C, and in the second row you do one thing, you add both of these results and place the result in the second row. So 1 minus 1 is 0 and minus B plus C, it is C minus B. You can do that according to property number 6. And now you see that you have a 0 at this position. So this entire determinant is very easy. This is this into this minus this into this. So if you do this, it is A minus B into C minus A, and if you multiply minus 1 with C minus B, it becomes B minus C, and this is the answer. So answer is, after solving this determinant, we see that answer is A minus B into B minus C into C minus A. Again, a very easy question and a very important question. Try to go through this several times if you have to, but try to understand it properly. Okay, let's move to another question based on the properties of determinants. So all of these questions are based on properties of determinants. Let us try to solve another question. Question is, using the properties of determinants, prove that determinant B plus C A B C plus A B C A plus B, this determinant is equal to 4ABC. So using the properties of determinants, you have to prove that this determinant is equal to 4ABC. This is the question, using only properties of determinants. Okay, so which property should I use? Always try to achieve zeros at this position. So if I do this, if I use this operation, that I change the first row to first row minus second row. If I do this, if I change the first row to first row minus second row, then what will happen? First row is getting changed. So second and third rows, they remain the same. So second and third rows, you write them as it is. Now first row is equal to first row minus second row. B plus C minus B is equal to C. Place it here. What is A minus C minus A? A and A cancel out, we have only minus C. Then we have A minus B at this position. Okay, so this is the determinant after we perform this operation on that matrix. So according to property number 6, this is equal to this. There is no difference in determinant. Okay, now what can we do? What can we do at this position? Can we see that the third row's first element and the first row's first element are the same? So if in order to achieve a 0 at this location, what should we do? We should subtract this row from the first row. So what do you do next? We change the third row to third row minus first row. So third row is C A plus B, and first row is this. So third row minus first row is C minus C is equal to 0. So we have a 0 at this position. Then C minus C, that means C plus C, that is 2C. And what is A plus B minus A minus B? So A plus B minus A minus B becomes a plus B. A cancel out, we have 2B. Okay, so after this operation we have 2B. After you perform this operation on this, we have this type of determinant. Now can we do any further zeros at this position? Can you see any further zeros? No, because this is C and this is B. These are completely different numbers. I cannot add them or subtract them and make them 0. So at this position we are left with only expanding this determinant. We cannot apply any more properties. So we see that if we remember the formula for finding determinants of matrix of order 3, then we remember that the sign convention is plus minus plus minus plus minus plus minus plus minus plus minus, sorry, it is plus and minus plus minus, okay, then plus minus plus. So if we choose this column, how do we find the determinant? Take C, then the determinant, hide the row and column. C belongs to first row, first column, hide it. You see 4 numbers, place them there. C plus A, B, 2C, 2B. Okay, the next element is B and there is a minus sign before it. So it is minus B, determinant. B belongs to second row, first column, right? So hide the first column and second row. What do you see? Do you see these 4 elements? Place them there. See, this is very easy. What can you do next? You can expand it. Now expand it. We cannot do anything on this. So C plus A into 2B is equal to twice BC plus twice AB minus twice BC. Okay, then minus B into minus C into 2B, this is 2 minus 2BC, then minus of twice AC plus 2BC. So here you see that 2BC and 2BC they cancel out. Again minus 2BC plus 2BC they cancel out, and what we have is 2ABC and minus B into minus 2AC. So minus minus plus, and we have 2ABC as well here. So ultimately we see that it is 2ABC plus 2ABC is equal to 4ABC. That is your answer. Hence this question is proved. Okay, using the properties of determinants, this question is proved. So always try to attain 0 at one of the rows or one of the columns by using the property number 6. This is the most important trick that I am telling you. Okay, let's try to solve another very important question. Okay, let me rub it out. Another important question based on properties of determinants. Question is, prove that if delta is equal to this determinant x, y, z, x square, y square, z square, 1 plus x cube, 1 plus y cube, 1 plus z cube is equal to 0, then 1 plus xyz is equal to 0. You have to prove that 1 plus xyz is equal to 0 if delta is equal to this determinant and this determinant equal to 0. So it is clearly giving you a condition that this determinant is equal to 0. So prove that 1 plus xyz is equal to 0. So how can you prove this? How can you prove this? Can you remember any property of determinant by which you can apply on this matrix? Remember, what is the property number 5? Please take a look again at property number 5. It was telling you that if you have a column or a row in which there are some addition of elements, then you can divide this determinant into 2 parts. One part will have the left hand part and the other part will have the right hand part. So I can say that this determinant can be written in this form: x, y, z, x square, y square, z square. Then on the left part I can have 1, 1, 1. Property number 5, take a look at property number 5, and plus again x, y, z, x square, y square, z square, then again x cube, y cube, z cube, z cube. Okay, according to property number 5, I can write this left hand side like this as a sum of 2 determinants, and according to question this is equal to 0. So according to question this is equal to 0. Now take a very good look at this determinant. Can you see that in this entire row x is the common factor. See, here you have x into x, you have x into x into x. So can you take x as common? Can you take x common here? So if you bring x in here, this becomes 1, this becomes x, and this becomes x square, right? In the same row, in this row, you have y as a common factor. So if you take y as common and bring it here, then this becomes 1, this becomes y, this becomes y square, right? In a similar fashion, you have z as common factor here. So you take out z outside the determinant, and then you can have 1 here, z here, and a z square here. Okay. Now you can see here that these two determinants have somehow taken shape. And what is that shape? You see that this is xyz, this is xyz, this is 1 1 1, this is 1 1 1, x square y square z square, x square y square z square. That means columns are similar, but they are displaced somehow. So can you remember a property by which we can change the columns, or you can interchange the columns? Yes, we see that the only column that we have to change is xyz should come into second position, and then x square y square z square should go into the third position, and this should come into the first position. So the first operation that you should do is that you should change this column. You should change this column and bring it here. So while doing that, will its sign change or not? So look at the second property, which says that if you change any two columns or any two rows, its sign changes. So if I bring 1 1 1 in this position, if I bring 1 1 1 in this position and xyz in this position, previously it was plus, now it will be minus. Okay. Now again, if I change this position to this position and this position to this position, then what will happen? If I bring xyz in this position and x square y square z square in this position, so let me bring x square y square z square in this position and put xyz here, then previously it was minus, now it will become plus. Okay. Now can you see that both these determinants have become equal? Both these determinants have become equal. So what is the common term here? It is plus 1 into this determinant plus xyz into this determinant. So I can take 1 plus xyz as common, and both of them get multiplied with this determinant. And this is equal to 0. So you see, this term multiplied by this term is equal to 0. So what does that mean? Either this term is 0 or this term is 0. Okay, so in this case, this term can be 0, and that is exactly what the question was asking you to prove. So it is right now proved that 1 plus xyz can be equal to 0, and that is the proof of this question. See how beautifully we have solved it. Try to practice as many problems as you like from your chapter. So let us look at the last example in today's class based on the properties of determinants. Last problem is, write a question, show that determinant 1 plus a 1 1 1 plus b 1 1 1 1 plus c, this is equal to a b c 1 by a plus 1 by b plus 1 by c plus 1. Prove that this determinant is equal to this expression. So how can you do that? Think about it for a second. I give you some time to think about it. Okay, now take the left hand side and do one thing. Try to extract a out of this row or column. How can you extract a out of this row? So you take this left hand side and try to take a as common term. So I can write 1 in this fashion as 1 by a into a, and this one as 1 by a into a, and I can write this as, how can I write this? Using this 1 by a type of notification. How can I do that? Can I write it as a into, or 1 by a, sorry, a into, can I write it like this? can I write 1 plus a as a into 1 by a plus 1? Can I write it? Yes, I can write that. So you can see that in each and every term of the first row, a is a common term here. A is a common term in all of the terms. So I can take a as common outside of it. So if I take a outside, so I will have a outside. According to property number 2, I can take a outside of here. In a similar way, I can take b outside of this. So I can write 1 as 1 by b into b. I can write it as b into 1 by b plus 1. I can write 1 as 1 by b into b. So you see that b is a common term. B is a common term. So if I take b as common term outside of this determinant, then we are left with this term. In a similar way, I can take out c as well, and we will be left with 1 by c, 1 by c, and 1 by c plus 1. Okay, so this is the matrix after we have taken out all of this term. Take a very good look at it and see if there is any mistake or not. Take a very good look at it. Okay, now since you understand this, then again use the sixth property. If you add all the three rows, if you add the first row, the second row, the third row, and you place the result on the first row, that means I am telling you to do this operation. R1 changes to R1 plus R2 plus R3. I can do that, and that will not change my determinant according to property number 6. According to property number 6, I can add this row with this row, and I can place the result in the first row. So my determinant will become ABC into, the first row is getting changed. First row is this plus this plus this. So 1 plus 1 by a plus 1 by b plus 1 by c. The first element is 1 plus 1 by a plus 1 by b plus 1 by c. What about the next one? 1 by a plus 1 by b plus 1 by c. It is the same as this. So the second element is also 1 plus 1 by a plus 1 by b plus 1 by c. And similarly, the third element is 1 by a plus 1 by b plus 1 by c plus 1. It is the same as this. It is the same element. Then the second row and the third row, they are the same. The second row is 1 by b, then 1 by b plus 1, then 1 by b. Then the third row is 1 by c, 1 by c, and 1 by c plus 1. Remember, this is 1 plus 1 by a plus 1 by b plus 1 by c. So again you see that in the first row, you have this term as a common term here. So again, according to property number 2, you can take this term common and take it outside. So if you take this term outside, what you will have? You will have ABC, and if you take this term from common from the first row, and this term is 1 plus 1 by a plus 1 by b plus 1 by c, and inside you will have 1 1 1 1 1 1, then you have 1 by b, then 1 by b plus 1, then again 1 by b, then 1 by c, then 1 by c, then 1 by c plus 1. Okay, see how easy it is. Okay, so now what can you do? What can you do next? You can subtract this from this, or you can subtract this from that, put the result here, again this from that, put the result there. Then you will have 0 0 at this position, right? So try to do that. It is ABC into 1 plus 1 by a plus 1 by b plus 1 by c, and perform this operation. That means C2 change to C2 minus C1. So C2, this is C2, change to C2 minus C1 in place in C2. So 1 minus 1 is 0. So first column is 1 by b, 1 by c. Second column is C2 minus C1. So this minus this is equal to 1. So place 1 here. Here you have 0. Then this minus this equal to 0. Okay. Then in the third column you do this operation. third column minus first column. You see 1 minus 1 is 0. Then 1 by b minus 1 by b is 0. Okay, and then 1 by c plus 1 minus 1 by c is 1. So your matrix changes to this. Now you can easily find the determinant, because in this row you have 2 zeros. So what is the determinant? Taking 1, you will only have this determinant. So this is equal to, if you rub it out, you have only 1 0 0 1 left. And what is the determinant? 1 into 1 is 1 and rest is 0. So this is nothing but 1. This determinant reduces to 1 only, and writing 1 or not writing 1 does not matter. So you see that the entire result has collapsed to this result: ABC into 1 by A plus 1 by B plus 1 by C plus 1, and that is your right hand side. And hence we say that we have successfully shown that this portion is equal to this portion according to using the properties of determinants. So that's it for today, and I encourage you to go through all the properties of determinants and try to memorize them. It is very important that you memorize each and every property of determinants, and in the next class we will solve some more problems from these properties of determinants, and we will solve an entire chapter's problem. Okay, so in the next class I will advise you that you go through all the properties of determinants one by one and try to make yourself familiarized with all the calculations involved with properties of determinants. So try to go through properties of determinants repeatedly again and again. You watch this video, and in the next class we will solve some problems. So till then, goodbye and see you in the next class.